Hello, hello. Here we are. Okay. We're on February 15th. The talk today is about,
Professor, you're muted.
pardon? Can you hear me? Can you hear me now?
We can hear you.
Oh, okay. Okay, so we're on February 15th, talking about requirements engineering this week's lecture. This says that the first deliverable for the project, which I've changed from P1 to S0, sprint 0, is due today. That's not true. That's actually due tomorrow. Before we get into the lecture, how is that going? That's not a good sign. Are there concerns?
Professor, can you hear me?
Pardon? We can hear you.
Yeah, it's just me and my team have some issue with the skill set that we have because I'm a minor, so I usually like self-taught myself, so I didn't learn Java as much that the other person team need to have to.
Okay,
So a little bit struggle there.
right. I tried to balance that. So, I would have tried to avoid one team that was all neophytes in terms of programming. Now, you don't have to use Java. That's not a requirement. But I think most teams will use Java because, you have to get their CS225 to get here. So that seems to be the unifying language. But you're not tied to Java. How about in terms of, okay, so that's an implementation problem. How about in terms of product definition, description, overall requirements, and starting to develop backlogs?
So one of my question about the product backlog is that so I have like, let's say the user stories like view the weather of a city, right? But there's like in the application, there's multiple ways for the user to click to view the city. So how can I interpret that in like the solution on the
Okay.
thing?
So what I'm hearing is you actually have several user stories. As a user, I want to view the weather in the city this way in order to blank. And then another user story. As a user, I want to view the weather in a city, method number 2. As a user, I want to view the weather in a city, method number 3.
Oh, okay, I got it.
And remember the format. As a blank, I want to blank, right? And then you can add on in order to blank. Other questions, concerns? That's a good one. I've received several invites to Discord servers. I have not yet had time to respond to those. I hope to do that tomorrow. Please, if when you're having your meetings, ultimately I'm going to I want to have a schedule of everybody, and then I can drop in as needed, or just, I just want to see some team dynamics. I do not want to interrupt the meetings. Do the Scrum Master and Product Owner turn in anything extra for this sprint other than the backlog from the Product Owner? So the way that works is the team turns everything in. And even with the backlog, I would argue, the team should be creating that, but the Product Owner gets the last final word on priorities. We don't want to overload the Product Owner. So the team should be creating these things collaboratively, and however you decide to divvy up the work is fine. But it should not be where, gosh, you know, the product owner is solely responsible for backlog or that kind of thing. Now, once you get into the sprints, when you look at that spreadsheet for the sprints, you know, I'm asking you to track your burn down for the sprint. And, you know, ultimately the Scrum Master is responsible for that. Ideally, as you go into your sprint, though, as you go into your Scrum meetings, you know, that's just a quick, okay, what'd you do? Ding, 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 ding. How much time do you have left? You know, ding, 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 ding on these tasks. And so it should not be a burden on the Scrum Master. As you may have noticed, the trick with this process is don't say, oh, we're going to fill in all that data at the end of the sprint. You won't remember it. It won't be right. It's unethical to make it up. So do it in little pieces along the way. I am concerned about, my concerns are product description, and I have a little concern with overall requirements because we didn't get a lot of chance to talk about that. You know, that's what today's lecture is about. But the idea is just to give some descriptions of things the software has to do, whether it's functional or non-functional. Most of it will be functional. Now, that's different, as we'll see today, than a software specification, a requirement specification, which has to be a testable item. These are not necessarily testable. They're just natural language statements about what the software has to do or a feature the software should have. And we can put should in there. You know, we're going to move to shall for the specifications, but for now, a should or would like, you know, these are more acceptable at this point in time.
I have another question. If
Yeah.
For the introduction of the homework S0, so yeah, I kind of confused between the introduction and the product descriptions. So is it the introduction is like the talk about the problem and then present your solution, and then in the part description we talk about the products, or?
Yeah, so we're not doing anything with solution yet. You're not talking anything about software design yet. You're talking about a description of what the finished product can do. And you don't have to have solutions, right? We're focusing on what it can do, not how you make it do it. And the introduction to any document is just a brief summary of, you know, what is this document about? Why do you want to read it, right? Those are the first two things that should always show up. What are we doing and why? And in this case, I would say, introduce the product as fast as you can. Here's our product. Here's our, you know, I'm using product instead of project because you have customers. So here's the product. Here's why we think it's a good product to make. And then here's the purpose of this document. This document is going to provide the following information. And that's all the introduction needs to do. It's introducing the topic. It is not discussing the topic.
Okay, so
And then in your, I'm sorry, go ahead.
so yeah, so when I was writing the introduction, I was like, oh, here's a problem that people interacting with, and we come up with an idea, and here's how to product. This is the product that we're gonna.
Sure. And that's okay to put inside the introduction, because remember, my view is what are we doing and why? So if you're introducing a problem that people have, that's the why.
Okay. Yes.
Right? People have a really hard time with this. Therefore, we're going to create a software tool to help them manage it. That gives a great reason as to why the product is a good thing to do.
Okay, thank you.
And then under the product description, it's here's what the software can do. If you were a user using this software, and think of it this way, it's kind of hard to do when you get embedded in writing these things, but you know, give it to a friend and have them read through, and then they should ask this question, you know, if I had this software, could I do this? Could I do that? You know, if I'm going to do a scheduling tool, oh, can I make recurring events? can I break long-term events down into smaller events, right? You kind of have to ask those questions of yourself and decide what you can do and what you can't do, and then answer those questions. And if you're leaving out some functionality, this is a hard thing to do. You are by definition leaving out an infinite amount of functionality, right? Because you're doing this much functionality, and then the rest of the universe is everything else. But within reason, you can say, here's what you can't do. Here's what the product will not do. Okay. The product will not magically read your mind and create a schedule. Right? The product will not scan your brain while you're asleep and pull schedule items out, whatever. But
Understood. Thank you.
Okay. And now you're not getting into it all how the software is achieving that. It's all about the what. More questions? Are we having any issues with participation rates? I have a really small keyhole view of that right now. If you're having an issue with participation from a team member and you don't want to publicly talk about that, you can always, I would say, first talk to your customers, and then they can always talk to me, or you can talk to me. But first go with use these guys, use Priscilla and Luke as your first line of attack on any problems that you have. They're doing this dual role of advising you and then trying to be your external customer.
Professor?
Yes.
For the Scrum meeting, isn't it basically like a check-in, right? Because you talk about what you've done, right? What's going forward, stuff like that, right?
Yes. Yes.
So I brought up the idea that maybe, because we had a really hard time trying to figure out when we can all attend meetings.
Mm-hmm.
Like we only had 2 days. There's like 2 interval times in 2 days that we could fit, right?
Mm-hmm.
So I propose that maybe like on a Sunday we could just all like message each other like what we've done, all right? Like in a Discord chat, not like attend a meeting, but like everyone during the day on Sunday would like type like what they've done so far, right? What's to come, what problems they're having so far. So kind of like a Scrum meeting, but like text based. Would that be a viable thing?
Yeah. So I've tried that before. And if you try to do Scrum solely by that asynchronous route, it tends not to work. But if you're augmenting your I'm saying face-to-face, your synchronous meetings, if you're augmenting your synchronous meetings with a tag up, then that probably will work. And that's what your team has to find out. You're going to experiment. So remember, you do need a good block of time to do your sprint planning before you go into the first sprint. And at the end, remember, you're going to do a sprint retrospective or reflection. And the purpose of that meeting is to say, okay, did that work? We all checked in on Sunday asynchronously. Did that work? And what I would do if I was going to do that on a meeting like that is make a form that's in a shared space, whether you're using Teams or Google Docs or Discord or whatever. Make a form that's in a shared space, and everybody fills out their part of the form. And you're exactly right. What have I done? What am I going to do before the next meeting? What have I done since the last meeting? What am I going to do before the next meeting? And what's stopping me? What problems am I having? Now, if you just leave it out in the air with what problems am I having without the team being able to address that, then obviously you may lose a couple days before you get back to your face-to-face or synchronous meetings. But I have no problem with that. Your team will decide if that really works. By the way, keeping records of these meetings is helpful for me because remember, your grade is going to be based on the team gets a grade, and then we're going to factor in participation rates. And it's nice if you had, like if you, Matt, if you said, okay, everyone's supposed to check in on Sunday and only 3 people are checking in on Sunday, I would like a record of that. So
okay.
I know how to score the individual. Unfortunately, we have to give individual grades, but Agile is based on team success or failure.
So we have our TA in the Discord as well. Would that be a form of like documentation, or would we actually have to like put it down somewhere, like keep a track of like when we're checking in or who's attending the meetings? And
it wouldn't bother me if I just had even attendance sheet. Yeah. Here's the problem. Your Scrum meetings are supposed to be short, right? 15 minutes, 10 minutes, where everyone's just boom, boom, boom. Here's what I did. Here's what I'm going to do. Here's my problem. Well, I don't want to add 10 minutes of documentation to a 10-minute meeting, right? That's not the point of it. But if you just give me attendance sheets, you know, again, it doesn't have to be for every meeting. You can have one meeting or one sheet that says, you know, here's all our meetings. Here's our 4 people. Check, 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 right? That kind of thing. And I'll know too by when I look at the burn down for the sprint, I should get some idea too, because if someone has a task and they don't update for, you know, for 10 days out of a 2-week sprint, that's telling me that they didn't work on the project for 10 days out of a 2-week sprint. Okay, so it's not critical that I get notes, but it's help. You know, I need some way of knowing participation. If the TAs are in the room with you and they get a good sense of the team dynamics, you know, I'm going to ask them. If you have any kind of just attendance sheet, meeting notes, if you have shared spaces where you're doing your asynchronous updates, and I look at that, or you can turn those in. That's why I want to pop into a few meetings too, just to see the team dynamics. Again, I don't want to be there for advice. I want to be there just to silently watch what's happening. You know, we'll do the advice outside the meeting. Does that answer?
Yeah, thank you.
Too much of an answer?
No, it's actually pretty thorough. Thanks.
Yeah, okay. Yeah, there's 12 teams, and basically these are 12 experimental labs, and what works for one team is not going to work for another team. Who's on there? Song, are you in Korea still?
No, I'm in here, Daytona.
Okay, all right. I was going to say your team might have a unique challenge, so okay, oh good. That may make life easier. People may not be in the same time zone. I had a class last year with Song was in Korea, and I had another person in it wasn't Kuwait. It was a Gulf state region. Well, that's quite a spread in time zones. Okay, so what works for one team may not work for another. That's fine. That's what we do not impose a rigid process in terms of mechanics necessarily. We're imposing this agile process where you have these milestones that you need to meet, but your team gets to figure out how you're going to meet them. Okay, more questions. Oh, how do we turn in these documents? You know, the assignment was made as an individual. That way I can give you individual grades. But the last thing I need is everybody on a team turning in 4 duplicates of a document. So I'm going to suggest that the best way to turn in in fact, I think I did disabled, you know, turning things in on the assignment. I'm not sure. I'm going to suggest that you go to your group discussions and take one zip file and put it there. That way I get one set of documents for the team. I can look at it and give the team feedback and then give individual grades. I'm pausing in case you have other issues. Okay, I think this was a fair amount of work for 1 week. And I think that this first sprint, what I'm hoping is you'll see actually a little bit of offloading of work, because you get to, your team gets to control the level of effort. So if you're finding that you've bitten off more than you can chew in that first sprint, that was something that at the sprint retrospective, you bring up in the team meeting. Oh, we thought this was only going to take so many hours. It took twice as much. It was really busy. So that helps you do time estimates later on and carve out your work for the remaining sprints. I would think you should fully expect that it's going to take at least 2 sprints for your team to get into a rhythm. Okay. Let's move to software requirements. Yeah, I posted these last night. Now, these notes were largely taken from Dr. Ochoa's notes, and he had and I kind of mushed a few note sets together and made some minor modifications to them, mostly about sequencing of the material, but some editing. So I want to credit Dr. Ochoa with these things. Okay, here's our outcomes. Again, you should ideally you can go through here and explain these to a stranger, right? So if you have someone who's not taken this class yet, and you can go through each of these and explain what each of these mean, that's how you know it. There's always a question, how do you know when you know something? A good test of that is, can you explain it? When you explain things to people, they have the nasty habit of asking questions. And then if you can't answer the questions, then that's a good sign that there's some portion of that that's still confusing to you. Okay, we'll start with the overview and start with some motivation. What is this about? Okay, the trick is building software, building the right thing. There's actually 2 things, and you'll hear these terms thrown around: verification and validation. And the trick is, a customer comes to you and they say they want to build, they say that they want you to build something for them. And the first question is, did you build the right thing? Did you really build what the customer wanted? And then once you answer that question, yes, we really attempted to build what the customer wanted, then it's, did you actually do it, right? We know what we were attempting, and then did we achieve it? So there's 2 slightly different questions. Are we even building the right thing? And then if we can answer, yeah, we are building the right thing, did we actually build it right? And the first part, are we building the right thing? That's an interchange between you and your customer. It should not be a top-down thing from the customer to you, and it should not be a one-time thing where they give you some ideas and you turn them into descriptions and requirements. It's a negotiated thing, and I'm hoping that the TAs that are serving you as advisor/customer, I'm hoping in the customer role, they're going to use their experience to negotiate with your teams to some degree. So your team is creating your own product. This is not normal. Right? In a real world, a customer comes to you and wants a product built. Your team is defining your own product. But I'm hoping that your customer will take advantage of their experience, and if they see that your team is doing something really nutso, that they talk you out of it. This business about having the customer, we talked about this early on. Why is software engineering hard? The customer doesn't always know what they want. The customer doesn't know how to explain it in software engineering terms. You as a software engineer don't know how to talk in their language, which might be farming or banking or diplomacy or game making or something else, or stock triage. So it's an interaction. This chart, if you see KAG, that's me. I added the note. This chart is talking about why it's good to do things right. If you get things wrong in the requirement phase and you have to fix it, it's dirt cheap because you haven't written any software yet. You haven't written any design documents, no test plans, no software, easy to change. The further you go down the road, the more dollars it is to change. So, get the requirements correct up front so that, halfway down the road, the customer's like, I didn't want that. I never asked for that. Or, this is completely opposite of what I said. As you go down the road, it's more dollars. And these dollar signs are historically accurate, but I think they're historical in the sense that this is the old waterfall model where you did your requirements phase first and then the design and then the code. In the agile world, I'm not sure about the value of the dollar signs, but the trend is absolutely the same. And again, in an academic setting, we rarely talk about maintenance, but in the real world setting, you put your software out there and it's not done at the end of the semester. Your software is out there for 5 years or 20 years or 30 years, and it has to be upgraded. Okay, simple definition, it's of a requirement. Now I'm going to distinguish now between requirements and requirement specifications, and I'm asking you for requirements in this first deliverable, not specifications. It's a statement that identifies the capability or function that satisfies your customer needs. Now your team is defining your own product. So you're going to come up with your own requirements. The requirements that you specify will generate user stories, and then when you implement the user stories, you have to test them to convince yourself that you did them correctly, right? That's what we built, and did we build it right? Are we building the right thing? Did we build it right? And you can't test unless you have a requirement specification to test against. So this is at the requirement level, which is then going to generate the user stories. You're going to have some weird user stories like we have to find meeting times. All right, so understand, communicate, and traceability. So the top one, understand. Shared situational awareness. Is the whole team understanding what we're trying to do here? You know, you've got a team of 4 people, and you may have, it would not be uncommon to have one person who at some point during this semester says, oh, I didn't know that's what we were trying to do. You know, at least with some part of your project. Once you understand, once someone who reads these requirements understands, then it's to communicate across the board so that all players understand, from the customer to the development team, to the business team, to the testing team, everybody understands because they've been communicated to. And then this notion of traceability, you're controlling things after that, right? Once somebody understands what they want, they've communicated it to everybody else. Now what you're doing is you're controlling. And the general rule of thumb is this: if it's not a requirement, don't do it. If it's not a requirement, don't do it. Why would you waste your time? In terms of business, why would you spend money on that? Meaning your company's money, right? You're investing time, your company pays you, they're losing money if you're doing something that was not required by the customer. In terms of academic, if I ask you for a four-page paper, why would you turn in a 60-page paper? In CS225, I asked you guys for 12 user stories. You know, why would you turn in 50? Now, some people did because they thought they gained value from that. But in terms of a grade, there was no benefit to that. So understand, communicate, control. And I did put a simple traceability matrix in the test document. So again, why am I running this test? Oh, because I have a requirement specification. Where the heck did that come from? I had to prove this user story was completed. Where did the user story come from? We needed to do this user story in order to meet one of the requirements, the initial requirements from the customer there that we negotiated with the customer. Oh, okay. So now if you're saying, why are you doing this test? You can answer that. You go all the way back to the beginning, step by step by step. And you can go in both directions. Okay, here's a requirement. The customer says this is a requirement of the software. They're not going to pay us until we prove that we met the requirement. Oh, okay, so here's where we can show them. We developed a user story to develop this. We have a software design where we believe we met the requirement in the software design, and then we have some requirement specifications to test that software. We actually performed the test and passed it. So now we can convince the customer from the top down that we did our job. So this requirements traceability goes both ways. Some top level stuff, requirements versus goals. A goal is a big fuzzy, gosh, we want to do this. Then the requirement is specifying, it says how a goal should be accomplished. Again, it's what the software is doing, not how the software is doing it. And then so this goal, the bridge example, the goal is big fuzzy, we call it motherhood language. You know, everyone loves mom and apple pie, so it's motherhood language. Build the safest bridge possible. Well, that's a crazy thing to say, actually, right? And so the requirement is actually telling you what safe means. It has to be able to handle this much of a load. It has to have a 50-year lifespan with maintenance, this kind of stuff. It has to be able to withstand a 4.4 earthquake, things like that. You know, in terms of aeronautics, airplane design, you know, what's the design point for your airplane? If your airplane has a hard landing, should the wings fall off? You know, okay, well, what's a hard landing? Is it, you know, banging on the runway versus smashing into a mountain? You know, you don't design planes to survive mountain crashes. So when you say, oh, I need a plane that is safe as possible, you have to define what that means. And in terms of like structural design, when people are building physical things, they have a rich set of language about that. Oh, okay, this thing has, you know, this airplane has to be able to withstand 10 Gs, and it has to withstand, you know, a 15-year service life, and there's all kinds of statistical ways to talk about that. Oh, and by the way, when we say it has to withstand 10 Gs, what we really do is we put in a margin of safety so it can really take 12 Gs before we feel like it's really in danger, that kind of thing. Software is tougher than that. How do I put in a margin of safety for software? That could be tougher. Now, you might say things like, you have to have a bandwidth of X, and then, you know, you have to be able to handle a bandwidth of X. And in order to convince yourself that you can handle that bandwidth, you build it to handle 1.1 times X or something like that. But often in software, it's rare that you can come up with this notion of a margin of safety. But you still specify what you mean. You can specify some things like reliability, right? How much is the system downtime? What's mean time between failures? These kinds of things can be specified. In this class, you are not going to do that, but you can specify software behavior. So that's the goal versus the requirement, and then the requirement versus the specification. The requirement is the need of the stakeholder. Who's the stakeholder? The customer. In this case, we have a perverse situation, right? You're your own stakeholder. You're coming up with the need as a team. And I'm asking our students, TAs, to act as external customers to guide you in that. Once you come up with your need, they're going to be the ones who serve as the external customer to, you know, you have to convince them you met the need, basically. Whereas the specification is a less ambiguously written way, that's what well-written requirement means, where you can build to it and test to it. So you can't necessarily build and test to the requirement, the customer need. Instead, you build to the requirement specification. Intuitively, hopefully you get the sense that the specifications for one requirement may generate many specifications. That one requirement will actually generate several user stories, which will then generate many specifications. And again, we tend to use these interchangeably. That's one of those situations where sometimes you really should be careful with your language and talk about is it the testable requirement specification that you're talking about, or the top level customer need? Okay, now there's a whole discipline involved with this. There are, you can take master's level courses, PhD level courses just in requirements engineering. And if you become good at requirements engineering, you become a very valuable commodity to your corporation or to your consulting firm. Because it's a tough thing. Requirements are tough, and that's the bottom line. They're tough. So people who are good at it, other people place a lot of value on them. I'm not going to read all the garbage here. I mean, I encourage you to read this stuff, but basically, you can see the highlights, right? It's a branch of engineering. Now this is about, notice this is a branch of engineering concerned with real world goals, functions of, and constraints. And then putting that all together to get the precise specifications. Notice they're putting they're kind of putting all three layers there, the goals, the requirements, and the specifications in that sentence. Now this next part though is those 5 elements. That's a good thing to pay attention to. Elicitation, or identification, analysis, documentation, validation, and requirements management. Now, of these, you're doing elicitation now. You're coming up with your requirements. Analysis of requirements, you're not going to do so much of. Not a formal process. Documentation as a specification, yes, you're going to do that. Ultimately, you're going to have the specification with the test plan. And then the validation is your testing and requirements management, you're not going to do so much of. So what's this? Motivation, project failures, lack of understanding, rush to start coding or designing components. But I should highlight that. Is this not true of every single one of us? Even those of us that know better? You want to try to do so, I'll start writing code. And pretty soon you're in this swamp of bad code. Not bad code, bad design. Right. Oh, I don't need to jot down a design first. I can just start coding. Have we not all been there? And will we not all be there again? Try to impose some discipline on yourself. I rarely get a chance to code, but when I do, I'm much more cognizant of making sure I have some kind of design before I just start, putting on the silk scarf goggles and typing away. Because I don't have much time, and it actually saves you time if you do the understanding up front, right? The requirements and the design up front. Yeah. Chris, I think you're about to come out of the woods with that. So. Zoom is in my way. All right, so software requirements, hard to understand. So here's some problems. Here's 3 basic problems. They're hard to understand. Natural language is ambiguous and imprecise. I used to teach regularly a course called CS222, which I hope all of you have taken. Those of you that have the CS minor didn't take it. I love that course. And a couple of you maybe had CS222 with me a few semesters ago. And what I love about that course is its entire job is to teach you how to get rid of ambiguity. And natural language is not the way to do it. So unfortunately, we typically put things in our software specifications in a natural language form. There are formal methods. By formal methods, think mathematical. So there are formal methods to try to do specifications. We are not going to require you to do that this semester. That takes a whole nother course or 2 to get into. So that's a problem. Natural language is ambiguous. I claim without proof every statement we utter is ambiguous. That's my claim. And you can test me on that. When you hear someone say anything, see if you can interpret it more than one way. And I believe you always can. Hard to understand, someone else's domain, business rules, customer may not understand what they want necessarily. That's not a knock on the customer. Just like you're learning how your team is going to work, the customer is learning how they're going to use a software tool that hasn't been built yet. And we know that. I mean, we've seen ERIU buying into Canvas and Workday and Campus Solutions and all these things. And once they purchase these things and the faculty and the students start to use it, then the faculty and students come back and say, it would be great if you had this functionality. And if they can add that functionality, they will. Or it would be great if you could modify how this is done. We're currently doing that with a lot of forms and processes in the university, like the add drop form, which I believe is online now. I believe. I could be wrong in that belief. Okay, they constantly change. Now you have to be careful about this. It's called scope creep. When you do a job, when you do a contract, you get something called a statement of work. And the rule is if you do all the jobs in the statement of work, you get money. Everything that's in the statement of work is in scope. Anything that's outside the statement of work is not in scope. And customers love to ask for a little more. While you're doing this, it's just software, right? While you're doing this, can't you also make the software do this tiny little thing, this tiny little thing? That's called scope creep. You have to be careful of that. And the other form is from inside the company. You might have a software developer or a software designer who's like, oh, this is so cool. While we're doing this, why don't we make it do this other stuff too? Well, if the customer didn't ask for it, what you're doing is spending company money that you're not going to get paid for. So that's called gold plating. Now, both of those are acceptable sometimes. For example, customer's going to pay us a lot of money. We're going to give them not just the product they wanted, but we're going to amaze them with how good this product is because we know that they're going to come back for more money. Right? So if you're trying to develop good customer relations, right, you might give them more than they asked for. And then they're so happy with you, they'll come back and give you more money, for another contract. Same thing with scope creep. Sometimes it's, okay, yeah, that really is not worth fighting over. So we're going to do it. The way Agile works is you and the customer should always be constantly negotiating. And so even if scope creep happens or gold plating happens, you do this in conjunction with the customer and do contract changes in order to make sure that, number one, everybody knows about it, everybody agrees to it, everybody agrees you should be paid for it, and then you get paid for it. They require time investment. Now this is the tough one. Now why is this not obvious? That's a real question. So you sit down and with your company and they want you to build software and your boss comes by a week later and they're like, why aren't you writing software? Well, I'm doing my software analysis. I'm doing my requirements analysis. That's perceived to be wasting resources. Now, what do we mean by resources? That's the business term for human, right? It's human time. And so people don't always build it into the estimates. And if you spend a lot of time on this, you may get pressure to stop doing that and start coding. And then Dr. Ochoa asked this question, why is this not obvious? Why is it not obvious? Any thoughts? Think from a business perspective. Think from a manager who may or may not know a lot about your job from their perspective. Let me ask you this. How many lines of code did you guys write this week for your project? 0. So you made no progress, right? Is that correct? You made 0 progress.
We do make some progress for sure.
Yeah. See the thinking though? The thinking is I pay you to write code and I don't see any code coming out. So therefore you're wasting time. And it's difficult to measure. It's difficult to measure costs that could have been saved by good planning versus the cost of actually working on something. You know what I'm saying? It's difficult to prove a negative. So if you go through and you do a slapdash set of requirements, that's what, yeah, that if you do, and some do, right? It depends on your company. But if you do a bad job of making requirements and then your software, it turns out to create the software, it took 150% of what you thought it was going to. People are like, oh, well, that's how software is. But what if you spent less time or more time on the requirements and then your software was actually 90%? You can't prove that that would have happened. You can't prove the thing that didn't occur. So it's a tough sell. It's a tough sell. Now, there are sometimes, people who will buy into this and then they'll give the, enough time for planning to occur. That even then, at some point, someone has to say, okay, enough planning, we've done enough planning, we're ready to start doing design and build type stuff. But that's why it's not obvious, and that's why there's pressure that you can get pressure against that. You know, even in this class, well, you've got 10 weeks to build out your software and 1 week to plan it. Maybe I should have given you 2 weeks to plan it and pushed all the due dates back. I was worried about doing that because then we're really pushing up against finals week. I wanted to give you a week of recovery between the last sprint and turning in the final things. Okay, and this is and you see my note there. I remember this cartoon when I worked in industry in the 80s, and this was before the internet, so people would take cartoons like this and copy them on the Xerox machine and tape them to their wall. And I remember seeing this one, and many others like it. And this is not a bad chart. It takes a little while to walk through. But really quickly, if you look at this Venn diagram and you say, you've got things that are desired by the customer, things that are specified by the requirements, things that are implemented in the code. And if you think about how those overlap, if it's desired, specified, and implemented, that's exactly right. That's where they all meet. That's where good code is. But look underneath that. If it's specified and it's implemented, but it was not desired by the customer, then it's gold plating. And if it's on the upper right there, if it's desired and specified but not implemented, clearly there's a problem with the code. The customer wanted it. We said we were going to give it to them, and we didn't. So you can walk through that Venn diagram. Okay. Activities. So now these are those 5 activities we talked about before. Elicitation is when you're working with the customer and your own team to discover what the heck is it that you want. And your team should have these, set aside a couple of meetings. It's a little late now, right? So hopefully you had a couple of real meetings where all of you together could voice your opinions. What is it we want to build? And that is not a top level, I want to build I want to build a computer version of a naval game called Wooden Ships and Iron Men, which was proposed and voted down, by the way. I was hoping someone would build that. So, okay, I'm going to build wooden ships, and we want to build wooden ships and Iron Men. Okay, end of meeting, we decided. No, you didn't. Right? You need to flesh that out. What does that mean? What is going to be incorporated? What won't be incorporated in that game? Oh, we're going to do, some people are doing like the infectious disease, right? The zombie game, or okay, we're going to do that. Okay, what are we going to include and what are we going to leave out? That's a sophisticated thing to do. Or the altruism game. Oh, okay, we're going to do the altruism game. Is that going to be a homogeneous group? Are we going to allow tribes? Are we going to have regions where the resources grow differently? How long do we let this thing go on to have real results, et cetera, et cetera. So it takes time. Requirements analysis. Now, I'm not asking you to do this. You may discover some on your own. If you start to put some requirements together, you could actually create contradictions. If you're going to meet this requirement, there's no way you can meet that requirement. It can happen. Oh, we'd never do that. In a small project like this, you may not, but in a large project with multiple teams, it may happen. Some requirements inconsistent, incomplete, vague, and wrong, right? There's all kinds of ways that you can have requirements that give you trouble down the road. These modeling techniques, some of these are formal, are actually used to try to find these kinds of holes and contradictions. But I'm not asking you to do any kind of real analysis on your requirements. It's just we think we got it, right? The team thinks we're good and the customer says we're good. That's being your TA advice. Specification, this is, again, we're going to go requirements, user stories, and then specifications from the user stories to verify that you've actually met specific behaviors within the user stories. But you'll hear the term modeling for this. I'm just going to try to use specification all the time. And this is where you're taking the more ambiguous requirements and you're actually putting them into testable forms. Informal techniques, natural languages, sketches, formal techniques, mathematical representations. My advice to you, if you can come up with a mathematical formula for a specification, that's the way to go. That's a good way to go. because you can say, the requirement is that this method that produces a result, right? It produces an integer-based result. It has to follow this formula. Here's the input, here's the output, here's the relationship between the input and the output. And then you can create test cases from that and prove it mathematically that when you injected this value into the method, that's the value that came out. Or if you injected the value into this method, this attribute was set to be a certain value. You inject and look. And then verification and validation. Am I building the right product? The two terms are used differently in different communities, and I'm not going to worry too much about it. Validation, I believe, is did we build what the customer wants? In other words, did the customer validate what we wanted? And then verification is did we build it? Did we build it right? So validation is are we building the right thing? Verification, did we build it right? These are that's normally how verification and validation works. Verification is usually is generally convincing yourself that you built what you intended to build. You built your software correctly in terms of your intention. And validation is, did I have the right intention? If you're doing, some of you might be doing simulations like modeling and simulation, then the way that works is validation is you validate against real world behavior. So if you're going to simulate a jet engine, and you have a mathematical model of your jet engine, you would validate it against real world jet engines. And then the verification is, did your software actually perform correctly internally? And requirements management, which we're not doing much of. I'm asking you to do one traceability page and that's it. As you would expect, there can be a whole discipline involved with this too, particularly as they change and you have to do change management. We're not too worried about change management in this short time frame, but that can be an issue. Okay. Questions over that? I need to pause so you guys can ask questions. The problem with a 2-hour lecture is I put you all to sleep. So get up and shake and move around or something, wake up. And then ask a question. Does this help you understand what I'm looking for in your document that I'm asking you to turn in? That's the main thing, yeah. And is it reasonable to assume that by tomorrow you can have that turned in? And by the way, you saw my note. I can be a little flexible with dates. If you guys are like, my team needs an extra day, I'm okay with that. Again, because just don't abuse it. You can't turn it in a week from now. And I don't know what the cutoff is, right? It's very subjective. I don't have a requirement for that. And I certainly don't have a requirement specification for that. It's very subjective. But your teams, as you've discovered, are going to have issues with meetings. So, if you need to start all your sprints on a Wednesday, that's what your team does, which means that you're out of line with my deliverable dates, and we'll all live with that. Now, I'm a procrastinator, so I know what I just heard. Hey, I don't have to do anything tomorrow. And I am so good at procrastinating. So please don't hear that. Please don't hear that. Yeah. Get it in tomorrow. But if you, for whatever reason, need an extra day on any of these due dates, then that's not going to be a problem. Try to let me know ahead of time, though. Okay, questions. All right, now we get into specification. When we talk about the specifications, again, those of you that took CS 225 with me, I was asking you to give me requirement specifications. Do we need to have the SRS? Yes. Now again, if the SRS needs another, wait, no, you don't need the SRS. There's only STD and backlog, isn't there? Someone check for me, I can't remember, but I don't believe the SRS was in there because the SRS is going to have the specifications and we're not doing that yet. Could someone verify that I'm right, that it's STD, backlog, and yeah, okay. Yeah. Now the STD, I'm saying that's where you're going to put not the requirement specification, but the requirements in there. Because again, that's describing The front part of that is describing what the software is doing. You're going to add to that later in the semester about how the software achieved it, right? The design of the software. Okay. Right. Good. So it's going to, and the reason I'm doing it that way is, again, you're going to have a text description of what the software does in paragraph form. And man, that's the most ambiguous language we can ever get. And then you're going to knock that down into some requirements, which really lays out in a bulletized form. It does this, it does this, it does this, it does this, right? And that's still a little ambiguous, but at least it gives you hopefully a clear summary of all the functionality. I keep saying functionality. You might have some non-functional things in there too, like it has to be written in Java, or it has to run on all different Windows machines, you know, things like that, right? It has to be. I hate this one. Appealing to the user, you know, that has no meaning, right? But it has to be maintainable. How do you measure that, right? This. Okay. All right, so specification. Here's the key now for the specification. This is when we introduce that word shall, the system shall. And this format that you see here, the system shall do something within, after, that's the great full form. You know, that should be, you know, tacked up on your wall somewhere. That's the format. Just like user stories, as a blank, I want to blank in order to blank. The format for there is great. And you don't have to use all of it, right? It's the system shall, right? Upon this input, right? The system shall upon this input, right? Or upon this operating condition. That's fine. And then it might be the system shall do such and such within a period of time. Harder to test, by the way, within a period of time after this condition is met. Okay, these are really hard to write. And here's how I suggest you write them. Write them down and then put on your unethical engineering cap and say, if I wanted to cheat the customer, how would I cheat this requirement? And what I find is when students first start writing these things, they don't understand how things could be cheated. Shall, so the system shall. Let's go back to shall. It's not should. The system should do this. Okay, I'm not even going to write code to do that. And I've met the requirement. It should, it doesn't, but it should, I met the requirement. So shall. The other thing to remember is that you want to stay away, you're still staying away from design at this point. So you want to stay away from specifying how things happen. Now there's a weird mix here, okay? Remember, we've got two major forms of creating software. We'll talk about more at the end of the semester. One is this, you do all your requirements, you do all your design, you do all your build, you do all your testing. And then in Agile, it's you are interleaving these things. And what I'm saying is you're going to have a requirement, user story, requirement specification. Well, it may be that you're going to incorporate more of the how in your system specifications than you normally would if you did them all up front. The reason that you don't put any how at all in the upfront ones is because you haven't designed anything yet. But now you're going to be designing, you're going to be writing specifications. You know, you might do some, again, if you want to write them all up front, that's fine. But if your team wants to write as you go, that's also fine. And if you're in, you know, once you're in your third sprint, you've got a lot of code written already. So you might refer to specific methods, specific GUI objects, which is really a how kind of thing. And that's okay at that point. So as try to keep the how out of it when it constrains your choice and you haven't made the choice yet. Right now in CS222, I've got students, right, they're turning in their project ideas and they're like, oh, and the GUI is going to have a button to do this and it's going to have a slide rule to do that. And I mark those and say, don't lock yourself into a button. You don't know if it's going to be a button. It's probably going to be a button, but why lock yourself in? There's going to be a mechanism, right? You don't care what the mechanism is. Could be voice activated. Maybe you shoot a laser at the computer. I don't know. But you don't have to lock yourself into the specific design yet. Now, that's a contradictory statement, like I said, because you will get into situations where you're saying, okay, I already have this class and I already have this class. I know their names. I know the names of the methods. And I'm going to say method A has to respond to method B with this result. Okay, that's okay, because you're putting this, you're building the requirements in the design as you go. As a rule, don't constrain your design choices, but you've already made those choices in the past. If you you can't say best and most, and you know, user friendly, easy to use, cost effective, those kinds of things. As you have experienced, those of you that had me for CS225, you know, I comment freely when I see those kinds of words in your writing. By the way, those of you that have, how many of you guys have had CS225 with Behi? Anybody in the room? Because he teaches it in the summertime. How many of you forgot who you had CS225? Okay, so this stuff is if you all had me in the past, hopefully you understand what I'm talking about, because I hammered you on your writing, you know, to the degree that it made sense. High quality, best, most, you know, you get a lot of that. The software has to perform this job as best as possible, you know, in the best way possible. I don't know how to measure that, or it's easy to use. I don't know how to measure that. The ones that are great are loopholes, if possible. The software should do this if possible. As a programmer, you just made my job really easy. It's not possible. I've just decided it's not possible. As appropriate. It's never appropriate. So don't, right? You don't want to put the loopholes in there. References. These are, again, if you can come up with formulas for things and you put the formulas up in the design document or early on in the SRS, and then when you're referring to them in the requirement, it's clear what you're doing. You never want to make a new definition in the actual requirement specification. If you're finding that you're having to define a term in the requirement specification itself, what the document is telling you is you need to go back and define the term up in the introductory text. I shouldn't say introduction, in the preparatory text that's describing the context. They fall into two basic categories, functional and non-functional. So functional is actually, you know, what does the software do? It says here, occasionally explicitly state certain behaviors the system should not do. Sometimes you can't avoid it. You know, stating a negative is hard to prove. You really, logically, you can't prove a negative. So stating what the system should not do. Sometimes, you know, you just can't get out of it. There's no way to express the positive form of that. It should not do that. So that's tough because it really makes your testing tough. So try to stay away from that. Can we change requirements? Yes. Yes. And you're going to find that some things that you thought you could do, you can't, and you're going to find, right? So, you know, one way to respond to that is to modify. There's two ways to respond to it. And to a degree, they are both okay in terms of your grade, in terms of points for your project. One way is to go back and change the requirement and change the product description. But notice what you're doing is you have a tail there. And this is, you know, one of the things you want to avoid is more work. So you're going back and doing more work. And the other way is to say, we had 16 requirements that turned into 45 user stories. And it turns out of those 45 user stories, we achieved 40 of them. You know, there's some threshold where I'm going to look at this and say, okay, we understand that you didn't achieve all your user stories, but that doesn't penalize your grade. Now, at some point, we were trying to do 45 user stories, we got 6. Okay, something happened bad here that your grade needs to reflect. How's that for an ambiguous answer? I would say the way to do this is have your requirements. If your customer, with your customer approval is basically, I'm going to put the load on them. With your customer approval, you can modify requirements. But I think a better way to try to do that is establish a set of requirements that your team feels really comfortable you can meet, and then have stretch goals, stretch requirements. And that way, if you meet all the ones, you know, one of the things that you and your customer will come up with is what's called a minimally viable product. It's the minimal amount you can do and still say you did the job. And that's where we're actually going to draw the line. But after that, once we just define a minimally viable product, then your requirements are fixed. That's a long answer. Did it make sense? Okay. I don't think in the agile discussion, I didn't talk enough about minimally viable product. So non-functional. Oh, okay. These are programming language. Privacy requirements, you know, that could become a functional thing too, right? But there's requirements that can be based on where you deploy these things. You know, you have to, what about you know, security requirements might be some. There are, you know, some of these are going to cross the line into functionality, in my opinion. So privacy requirements, that's actually going to be, can be converted into a, you know, thou shalt kind of statement about how people access the system. Same with any kind of cybersecurity, quality of run. Now the runtime, the time between failures or the quality of service, that's non-functional. If you notice, like, you know, you try to log into Ernie on a Sunday night, and, you know, sometimes they tell you ahead of time, well, we have to have downtime every 3rd Sunday. Well, what are they giving you? They're giving you a quality of service measure, you know, a reliability measure. Those are tend to be considered non-functional. Because when you press a button and the thing happens that you wanted to happen, that's not a reliability issue per se. The system availability is the reliability issue. I mean, a few years ago, it was always, you log into Ernie, it took 3 times to log in before it didn't give you the error page. And that wasn't too many years ago. It was not reliable. Okay, you can walk through this. This is, again, a taxonomy of these things. Oh, scope, understanding, volatility. Here's where it addresses your question, pitch, volatility, knowingly specifying requirements that will change. Okay, you're not going to do that knowingly. However, I would be shocked if the requirements that you guys write for this first deliverable are 100% intact and unchanged by the end of the semester. I suspect you're going to add to them and modify a couple of them. I don't think you'll remove any. But at some point, what we're going to do is work to say, okay, here's the functionality for this minimal product and these other ones. If you get them, wonderful. Understanding is always tough. That's why, you know, I'm a formal person. I like formal notation. I like formal languages. When I say formal, think math, both Boolean math and algebraic, you know, calculus type stuff, because the whole point of a formal system is to reduce ambiguity. That's its whole job. And scope issues. Let's see, let's walk through this, a requirement specification. helps engineers to accurately describe what the system should do, helps engineers to understand what the customer wants, establishes an agreement. See this, see this is a nice thing. You're getting an understanding of what the customer wants. Now, what is that different? Wait, aren't those first two the same? Understanding what the customer wants and understanding and describe what the system should do. Aren't those the same? I'm wrong. Tell me why I'm wrong. Where do you see a difference in those two? In my case, the system doesn't always do what the customer wants. In my case, it never does what I want. But it should, right? It should. So that's why we're helping the engineer to understand what the customer wants. But what's the difference between understanding what the customer wants and describing what the system should do? This is the difference between what and how. Understanding what the customer wants, what do they want, and what the system should do is moving into the how did we achieve what the customer wants. In fact, I think we should change that line to help the engineers to accurately understand how the system achieves it. And of course, the third one, establishing an agreement. That agreement is important. Your team should have a shared vision of what the product is. If if we pull the police interrogation trick and pull each one of your team members into a separate room with no communication and say, tell me about your project, we should get the same description from all four people. At least not radically different descriptions. And the same thing with your customer. The customer, now, your customers, Priscilla and Luke, they won't know as much about your product as you because they're managing 6 teams, and that's a lot of work. I hope though your team develops a good relationship with them, interacting with them nearly as often as you're interacting with your team. It doesn't have to be a big interaction. All right, we put this stuff in the SRS. I'm not going to spend a lot of time on the SRS because I've given you a large template, and I'm going to give you a reduced version of that for your own purposes, for your team to fill in when we get to that part. Standards. Now, what is important is standards. One of the things that we should teach in engineering schools are standards. They do exist. And in the world of computer science, software, electrical, and computer engineering, the IEEE is the body. It's this giant professional organization, largest professional organization in the world. Hopefully all of you students who are in the EECS department are members of the IEEE. Just like those of you who are in the AE, I hope you are members of AIAA. And they have standards for everything. And as you know, the FAA has standards for everything. And ISO, the International Standards Organization, has standards for everything. And one of the things that as an engineering, our goal for you as engineering students is to understand that, number one, that standards do exist. And number two, that the standards that are relevant to your discipline, what are the primary ones? For example, ethics. IEEE has an ethics standard, just like the university has an ethics standards. So there are standards for requirement specifications. For software, if you go to mechanical engineering, you're going to find other standards for requirements specification. What's the auto group? I can't remember the ASME. Is that it? Or is that mechanical? Who knows in here? We've got a bunch of different disciplines in the room. ASME? Oh well. Your discipline has standards. This is one of them. The document that I've given you this document as a supplement to the slides online on Canvas, so please just look at it. Don't freak out. You don't have to do the entire, you're not going to follow this exactly, but it gives you an idea of what kind of things we're talking about. So in terms of this, if we just walk through this outline, introduction, purpose. So what's the purpose of this document? To provide a specification for the requirements. Scope, product overview. So now you're going product overview. Now, what you do here is you can give a shorthand definition of what your product does, and you can refer to the software design document because you've already done some of that work there. But look at number 1.3.2, product functions, 1.4, definitions, and then in section 3, it's specific requirements, or should be requirement specifications. You fill in, as particularly, let's look at 3.4, you would put in basically your performance requirements or your functional requirements, requirement specifications. And if you have to say, define something down there, you're not doing it right. That should be up in 1.4. So what I'm going to do is take this document, and I've already kind of stripped it down somewhat to give you a working template for this class. But you can see the kinds of things that people put in these documents. And if you look in the document, it'll tell you inside of each section basically what you're supposed to put in there. It's a good read. It's good to know this stuff. I like this. It carves the universe into 2 sets, all systems satisfying the user's needs and all systems that do not satisfy the user's needs. It's nice that those are disjoint sets. And we should say all systems satisfying all users' real needs, all systems that do not satisfy all users' real needs. You do a partial, you would think that you're in both at the same time. No, these are disjoint sets. Basically, systems that the customer is more than happy to pay you for versus systems that they begrudgingly pay you for or refuse to pay you for at all. Boy, this sure sounds like a slide we had a while ago. Remember, the other one was understanding, communication, and controlling. That's what the requirements were about, understanding what we want, communicating to the team, controlling the build. And now it's communication again. Now, instead of understand, communicate, control, it's communicate, test, control. Now, this document, I expect, again, you can do this 2-way. I don't care how you do it. Your team gets to decide. You can try to write all your user stories and all your specifications for the user stories up front. That's your business. And then you're going to put them in this SRS. I suspect even after doing that, you're going to modify some as you go. But what I really expect most teams to do is you're going to get as many user stories as you think you know up front, put them in the backlog, and you're going to pick some for the first sprint, and then you're going to build the specifications for those user stories from there. And so you're going to turn in an SRS in iterations that gets built just as your software gets built. It starts out as a walking skeleton, your software does, so your SRS should be a skeletal SRS that only addresses what you've built in software so far. That's what I suspect most of you will do. But I don't want to constrain the teams. I want your team to decide what's the best way for your team. Right? You know, I don't know if I'm a good manager or not, but a good manager, they give you what you need and then they get out of your way, right? I want to get out of your way. If I really wanted to get out of your way, I'd stop asking you to turn stuff in. Right? It's the official statement of what's required. Oh, okay, that's good stuff. Again, this is about understanding and agreement. Now, think about how this works in a business setting. If you have a customer, the customer tells you what they want, and then you have no visibility from the customer at that point on, and you build an SRS internal to your company, but the customer never gets a chance to look at it. And that's the official statement of what's required. My guess is the customer is going to want to see that thing and they may want to help you with that thing. In your case, your customer should be reviewing that thing. And again, it's not design. This is about what. We're not saying, we're saying what the system should do, not how. So when you say, oh, this method should have this functionality, this method should compute, I don't know, Fibonacci sequence. We're not saying how it's done. We're just saying that the result is a Fibonacci sequence. How do you make a Fibonacci sequence? That's a different question. That's the coding part. And again, if you don't have the requirement, you shouldn't build it. Now, I'm going to have, and I'm going to be interested to see how you guys experience this, and we may have to negotiate as the semester goes on. How complete does your requirement specification have to be? I don't know the answer to that. I don't know. If you've got, in a given sprint, 10 user stories, and let's say those 10 user stories would give rise to 30 requirements, and then do those 30 requirements would probably gives rise to 150 test cases, right? Is that achievable? I don't know. I don't know. I need you guys to help me with that, and we'll need to find some, I suspect, some middle ground. So if your job, let's say you get a sprint and your job is to do 2 user stories, my suspicion is, first of all, your team has to agree on what it looks like for that user story to be called complete. That's required. That's part of the process, the agile process. From there, you might write 2 or 3 requirement specifications for each one. So you're looking at, let's say, 5 requirement specifications for each one. And then each one would have 2 to 3 test cases. Now, again, if you do all that in real time and you keep up with your documentation, not a bad thing. But if the teams are finding, you know what, trying to test everything is killing us, then it might be, okay, maybe we test, we pick what are the critical user stories and just test those. That kind of thing. I am honestly unclear on how that's going to work, because I am honestly unclear on what the task level is. So I'm going to need some feedback from the teams, and we're going to have to do some negotiation between, again, work it first with your customers, and then we'll work it with me. Does that make sense? Ideally, I want you to test every user story, at least 1 test per user story. Maybe that's the rule. At least 1 test per user story. And your team has to make a decision as to what special user stories might need more testing, might need more tests. I don't know. Oh, by the way, here's how you can make life easier for yourself if you use the automated testing. So JUnit testing, I think GitHub has some unit testing features. If you do that, it actually is not a hard thing at all. You build the tests as part of building the code, and then the tests run automatically. And every time you change the software, all those tests can get run automatically. Not a requirement, but helpful and a good skill to have. Okay, behavioral, non-behavioral, we've seen this before. Why organize? I'm not going to go through this slide. Representation. Go through these lists here. So the functional mode, what is the portion of the software that's being that is doing some work? User class, who's doing the work? Can you identify the actual objects, methods, that kind of thing? I think if you develop as you go, you know, you're going to have some software development followed by, for the next iteration, your user stories and software and specifications. I think it's fair to refer back to the software that you've already created. The stimulus. Now here, let me talk about stimulus for just a second. The stimulus is, everybody thinks the stimulus is the user pressed a key, you know, pressed a button on the keyboard or pressed a mouse or something like that. The stimulus can be internal. If you have a method and you want to test that the method was built correctly and that method has input parameters, you are allowed to have a test case that injects whatever values you want as the input parameters. You don't need the user to do anything. Automated testing, build a method that does the test, build a test class that does the test. If you use the JUnit tools in Eclipse or similar tools with whatever system you're using, you can build those tests, as I said, and they run automatically. So don't think of stimulus as the human user doing something. Anytime a method is called or an action is taken, there must have been some stimulus to make that action occur. And as a test case, you can specify exactly what the preconditions were and what the inputs were to that method or function so that you can specify exactly what's supposed to come out of it. Think of it in terms of I want to test this specific function, method, whatever. How would I do that in a standalone world if I just kept calling that function? Who uses this thing? Okay, customers, managers, developers, customers so that they're pretty sure that we're building the right thing, managers so that they can plan things out, developers so we know what the heck to build, test engineers, you're all of these roles at the same time, test engineers so they actually can develop tests, maintenance engineers and other stakeholders. Well, that's a catch-all. We don't worry about maintenance again in academia, right? You build your project and then you probably never see it again, which is unfortunate. That's why I hope you build something that you can take with you and keep adding to it. We've already talked about that. But there's some good stuff coming up here. And this has some examples. That's what I like about this section. In the event of a power outage, the system shall support basic operations while being powered by a backup battery. Now, what the heck, is that good or bad? Is that a good requirement or a bad requirement? If it's bad, what kinds of things are not so good about it? If you look under the second one, that kind of answers the question. In the event of a power outage, the system shall support basic operations while being powered by a backup battery. Now, again, you need to read these things while you're writing them, and it's hard to do. If you write one of your team members should read it and ask tough questions like cheating it. You know, how could I cheat it? How can I cheat that requirement? Well, let's see. I don't think any operations are basic operations. That's how I cheat that one. That's one way to cheat it. I don't think there's any basic operations, so I don't have to do anything. Or I'll support basic operations while being powered by a backup battery. Okay, my backup battery lasts 2 seconds. Always be kind of a prick when you're reading these things. You know, you've ever had an argument with somebody and they keep changing the definitions of words on you. They keep twisting your words. That's the person you want to be when you're reviewing your own requirements. How can I twist these words to mean not what I wanted? So in the bottom, it's a little better. In the event of power outage, the system shall support operations A, B, and C. So they didn't say basic operations. They said these specific operations for 30 seconds. While being powered by a backup battery. By the way, instead of a battery, you know, nowadays you can get a capacitor bank that will last for 30 seconds or longer. If I did a capacitor bank instead of a backup battery, have I met this requirement? Have I put you to sleep? If I met this with a backup, with a capacitor bank instead of a battery, I would say technically I have not met this requirement, which puts you in the weird situation where you met the intent of the requirement, but not the letter of the requirement. And therefore, if backup battery is not needed as a strict mechanism, right? That's a how, not a what. So maybe it should be powered by a backup power source, right? Now we're saying what we need, but not how we achieved it. And we can have other requirements about what that backup power source needs to have in terms of voltage and how long it's active and things like that. You can almost always improve these things. Here's another one. The system shall provide a response to request A within 5 minutes of receiving the request A from the user. And then the next one, the system shall provide a response to request A in 5 minutes of receiving the request A from the user. What are these different? Where's the differences in those? I think I'm missing something. Oh, system should in 5 minutes or within 5 minutes. Within 5 minutes. Now, by the way, even that is tough. If you started out saying the system shall provide a response to request A within 5 minutes of the request being made, that's ambiguous because you don't know what it means for the request to be made. Does it mean when the user hit the button? Or does it mean when the request hit the system? Remember, in an internet world, you may have lag times, and that lag time may be 3 or 4 seconds. That might make a difference. There was a study that one of our professors did several years ago on a military aircraft, and they would, the pilots would enter data into a onboard computer, and then they weren't getting results back. And it turned out just the lag that it took for that computer to talk to this system, to talk to this system, to talk to this system, to talk to this system. Sometimes the lag was so great that basically they thought they didn't get a response and they were already trying to enter in a new thing and it screwed up the system. So be aware of, there's all kinds of ways to get lack of clarity in these things. Conflicting behavior, conflicting terms. Oh, once you define a term, use that term always for the same thing. Never use that term for something else. Never use another term for that thing. Traceable. Again, this goes to customer goals, requirements, in our case, user stories, requirement specification, test. There's a software product in there somewhere. That's user story, software development, software design, test. Requirement specification, software design, test. Test of that implementation. Why are you doing this test? Oh, because I had to meet this piece of functionality. Why did you need that functionality? The customer wanted it. Oh, I had to meet that user story. Why do you have that user story? In order to meet a requirement, which is a customer need. And again, you should be able to go back and forth. If I looked at one of your requirements in your software design document and said, prove to me that you met this requirement, you should be able to say, oh, okay, here's how we did it. This requirement generated 4 user stories. Those 4 user stories generated this code and these requirement specifications, and then we put in test cases so that we could do the test cases of these requirement specifications against the code, and we passed them all. Origin, clear. Okay, now here, look through these. These are good examples, right? The system must be user-friendly. How do we verify that? You can kind of sort of do that. Don't they put out beta releases and they ask the customers if they're happy with how the thing works, that kind of thing. User interface shall be menu driven. It shall provide dialog boxes, screens, radio buttons, drop down, right? Now, first of all, I'm not thrilled with that because it's a how, not a what, but sometimes that's a requirement that the customer wants. Well, if the customer wants it, the customer wants it. Is that verifiable or not verifiable? That's a tough question. It might be that you provide these things, but they don't do anything, or they do the wrong things. So maybe you met that requirement, but not in the other one. The system shall usually generate an output within 10 seconds. That's a tough one, right? What the heck does usually mean? If you want to do that, then you have to, if you want to usually, you have to put in something measurable. The system shall generate an output within 10 seconds, 90% of the time. That's measurable. You just run 1,000,000 tests and do statistics. The system shall generate output B within 10 seconds of event A occurring. Now, see, again, it depends on what you mean by event A occurring. You might have to define that somewhere. And output B, you might have to define that somewhere. Now, within is good. Within, because 10 seconds or less. If it's at 10 seconds, that's impossible. What if you have a timing issue where you actually need, this happens and this is supposed to happen exactly 2 seconds later? How do you handle that? You say 2 seconds plus or minus 0.1 second. That's measurable. Just like in the mechanical world. Don't you guys do sheet metal thicknesses? Plus or minus 0.01 inch. You do dimensions, often plus or minus 0.03 inch. Well, that's measurable. Same thing here. The system shall respond to users' requests quickly. Clearly, that's not measurable. Within 2 seconds. Oh, that's getting better. Now the system shall respond to users' request A with result B within 2 seconds. Why did they add that? The system shall respond to users' request A within 2 seconds. No response is a response. Ignoring you is a response. So we say specifically what the response should be. These are good to read through. Completely reliable, modular, fast. See, none of these are any good. Errors in the system shall be less than 99%. It depends on how well they defined all the other things before that. But that's a tough one. It's hard to measure. 99% of what? Of all the operations it's performed? That's a tough one. Cyclomatic complexity of each module shall be within the range of 10 to 40. That's a measure of your design that we don't talk about in this class, by the way. Okay, you can go through these. We're getting late. Why do we care? We've gone through this. Correct, complete, consistent, traceable, verifiable, unambiguous. As far as possible, unambiguous. That's why if you can do mathematical operations, that's best. Okay. So the Agile caveat, the SRS is not necessarily required under Agile methods. Some methods actually shun documents like this. Some crystal clear, the code is the documentation. So there is a little bit of a contradiction with asking you to do a SRS in an Agile environment. However, a lot of Agile environments do ask for an SRS and a SDD. And it's good to know these things, right? We don't want you to only know Agile with no documentation and not know how to do anything else. We don't know where you're going to end up working. These are good things to learn about early on and to get practice at writing. You get practice here, and those of you that are in the EECS programs and you take the capstone course, you're going to get practice writing them again there. Okay, we're at the end. Who's awake? I'm awake. I have a question for you then, Mr. Awake. Should we keep the class this way, where we do one long lecture on Monday and then office hours on Wednesday, or should I break this lecture up into a smaller portion on Monday and smaller portion on Wednesday? Brandon's, I've got 1 vote for splitting it into 2, which would be Monday, Wednesday. Benny says split. Benny says, someone says, oh no, I think I'm going to open up a survey. Yeah, that was my thinking, Alik, is if I put everything on Monday, then you know, it gives you more freedom throughout the week, because I'm really worried about time, you know, you guys find the time to meet with your teams. On the other hand, as you know, a long lecture, especially via Zoom, is okay, I think I'm getting most people like it. So let's see, I'm going to open up a survey. If I don't open it up by tomorrow afternoon, please someone, you know, ding me on Canvas and remind me. I'm going to write it down. So I have a higher probability of it actually happening. Side note, is there a way to keep the Zoom code for each lecture? Yeah, I can make them all at once. Is that helpful to do that? Since I made all the office hours the same. I made it one meeting with, I don't know, 15 repetitions or something like that. So yes, I can do that. I don't know why I'm resisting that. Is that something that's important to do, Brandon, or everyone? In other words, just schedule all these lectures as one Zoom meeting. The other thing that with this too is, once I upload this to Canvas, you can always just watch snippets of this, right? So if you found that you kind of drifted out during parts of the live lecture, by all means, you can go back and pick it up in 15-minute increments or whatever you're. Yeah, okay. Yeah, I try to do that. Actually, Michael, if I'm doing my job, I would actually do that on Friday. That's my goal. So Sunday is helpful, but I'll try to get those out on Fridays. Okay. I think I've got most of the class organized so I can stay ahead, but yeah. All right. Well, are there other questions before we go? Any other comments? Okay. All right. Thanks for being here. Have a good rest of your day and a good week. And if you need stuff, talk to your customers, talk to me.